Okay, we're going to talk about addition. Okay, I want you guys to try and think about what addition is. If you were to describe what addition is to somebody that did not know, what would you say? Okay, this is tricky when you have really basic vocabulary words. So what is addition?
So if I was explaining addition, I would say, like, if we had 10 yellow Skittles and 10 red Skittles, we would just be adding those together and counting out how many you'd have total of red and yellow Skittles.
Okay, good. Anybody else have a thought? What is addition?
It's combining two values to make a new value.
Right. You guys are all on the right track. Okay. Anybody have any other thoughts before we move on? You guys have the right idea. Addition is like combining groups together. Now, it's important that these groups be the same thing. They're like each other in a certain aspect. Okay. Like what Camille said with Skittles. Other people are saying different, talking about in generalities. Okay. The quantities must be like each other. And so what helps me understand is that there's a common phrase that we use called you can't add apples and oranges together, right? And so apples and oranges are different things. So you can't really add them together if you consider them as an apple and an orange. If the attribute is fruit, then you can add them together and you can have like a certain number of pieces of fruit. But apples and oranges are different, and so you can't really combine them together unless you think of them as a different way. Okay? So combining objects. The addition is the act of combining two or more like quantities. Okay? The result is a sum. Okay? So the answer to an addition problem is sum. So sometimes we'll use that word, sometimes we'll use total, all of those things. So, and here's another question. So we got addition down. What do we add? Well, we add representations of objects, which we use numbers to represent them, okay? And so can anybody tell me or describe, you guys can hear from a few of you, what are whole numbers?
A whole number is like anything like 1 and above.
Okay, you're
like,
close.
Isn't it like 1 through 9? Because 10 isn't a whole anymore. It's like a different thing. Or am I totally off?
You're close.
It's anything.
Anybody else have an idea? Whole numbers.
In the chat, somebody said something.
Oh, yeah, they said that for addition, the sum of its parts. And there's another one that someone says it, an integer. Okay, so we've heard these types of numbers being thrown around. And we're going to go ahead and go to my iPad, and then we can talk about some of these things. So I'll screen share there. And so this is kind of like the whiteboard type of a thing. So what we have is, and so what I have is I have some lesson plan notes I'll go ahead and share again. So you can take regular notes in your notebook if you want. But we're talking about whole numbers. Now whole numbers, so we can start at, and I do this a little bit in 2020, but since we did have people ask about integers and whole numbers. Whole numbers, we'll start with the counting numbers. Okay, that's the 1, 2, 3 that Camille is talking about. Now they do go on forever, and counting numbers will go on in like infinity. Okay. You just keep counting. But the idea is that in counting numbers, you don't have any fractions, you don't have any decimals, okay? You don't have any negative numbers, you don't even have zero. Okay? So we're gonna put that in a group there. Okay. The next level of numbers are the whole numbers. And whole numbers are the counting numbers, but they do include zero. Okay. So put a big circle around that. And then the next level is the integers. Okay. The integers are the negative numbers. And the whole numbers. Okay. They're all in one big group there. Okay, so that's where we're going to stop now. We have more numbers in 2020. But for arithmetic, you know, we don't really, we'll do from some fractions. Okay, we'll do fractions. Okay, those are the rational numbers. Okay, rational numbers are fractions and decimals. They're any number that has the form a over b, where a and b are integers. Okay. We'll probably get to that when we get to fractions, but that is all encompassing there. Okay. So there's our little spiel on the types of numbers that there are. Okay. And so if you guys want to copy that one down more, you can. But we do talk about numbers, and we do put them in an order as well. Okay, because we have, when we talk about numbers as a collection of objects, okay, the whole numbers I have no objects, one object, two objects, three objects, right? We can also put them in a certain order to reason about them. And when you put them in an order, we call them ordinal numbers. Okay. So we have the regular numbers. You can use whole if you want. Okay, those are called cardinal numbers. Okay, 1, 2, 3, 4, 5. And we use cardinal versus ordinal, even though there's lots of other types of numbers. Okay. So if you have numbers used to designate an order, like first, second, third, you might have heard these numbers before referred to as ordinal numbers. Okay. So those are a couple of bullet points here that the book goes over. So cardinal numbers are used to count objects. And so if I want to convey like how many marbles I have to another person, I use a cardinal number. I have 3 marbles, 4 marbles, or 5. You know, they're great for communication. If I want to use a certain order, like this is my first marble that I've ever owned, you know, I give that to my friend, then I use ordinal numbers. Okay, and ordinal numbers denote an order. Okay. So that's the first part, was about some of those types of numbers. Okay, so that was part A. Now in part B, for our lesson today, we have 3 parts. We're going to talk about different types, 2 types of models. Okay, if you want to model an arithmetic situation, like in real life, models are used to help us communicate, to help us solve problems. And so there are 2 types of models that we're going to talk about for doing arithmetic. Okay. So the first one, so this part is called models of arithmetic. Okay, model is something that is like a situation, but not exactly the situation. It's something that you can use in your own space. Okay, certain models. We have the first one is called a set model. Now, a set model is a collection of objects that you use when you represent an arithmetic operation. Okay, so Camille had used Skittles before. So Skittles are a set model because you have individual objects that you can put together, you can take apart, you can put sets of them. Okay, so those are set models. Another example, is that we can do like apples. Okay, the set model is apples. So here I'm drawing 3 drawings that probably look somewhat like apples, but not really. But we can use our imagination, right? And we have the number 3 with it. So 3 is an abstract number if it's just by itself. But if you take it and put it with a unit or an object, it's called a quantity. Okay? So 3 apples, and then we have those apples there, and we can have another quantity or for set model. I'm going to do 4 oranges. Okay. So those are 4 oranges. And I can do things with them. I can put them together, take them apart. We can have, and as I used apples and oranges, we can also have 7 pieces of fruit. If you want to think of them as that way. Okay. So all together. Let me draw this in a different way, and it's a little bit better. Okay. So those apples and oranges. So we're gonna have some red apples. And orange, I have to find it on here. So orange. Okay. So you have this, and there's 7 pieces of fruit there. Okay. All right, set model. The other type of model is a measurement model. Okay. Measurement model is a set of numbers that are drawn from a scale, a continuum, or a spectrum. Okay, so for set model, you have them objects, you count them there, that's the numbers. But measurement one is also used very frequently. You can take any number from a scale. I'm trying to think of other words to describe this, and I thought of continuum and spectrum. Some sort of measurement without using the word measurement itself, but the easiest thing to do is to think of measurements, okay? So an example of that you can have is like the number of miles from school. You can think of them all together, but you can think of them separately as the number of miles from school where you are at presently, but they all kind of run together, you know, so they're not like really set apart like objects are. Okay, and so we can put school here. We can draw like a number line to say that this is where our home is. So let's say we're at home, here's school. Okay, 0 miles away, 1 mile away, 2 miles away, 3 miles away, and 4 miles away, for example. Okay, so using distance is a measurement model. Okay. Another measurement model is time. Okay, so I'm gonna put this here is distance. And time, so in the book they use time, number of seconds. Timed, let's say you're timing a race or timing cooking or something. Okay. So they have this depiction in the book of like this little thing. You know, some sort of timer. Okay, so time is a measurement model. And then our final example is like the number of pounds. You can use weight. You can use weight as a model, of measurement model. Or how tall something is, how long something is. So those are all measurement models. Okay. So if you guys get the idea of what a measurement model is. What we're gonna do to solidify that is we're gonna have like this exercise where we have which is a set model, which of these examples is a set model or measurement model. Okay, so our first one is going to be the answer to the question. So the question is, how many shoes do you have? Okay. So does anybody know if that's going to be, the answer to that would be using, you can answer that with a measurement model or a set model. How many shoes do you have?
Would be
Set
set
model
model
or measurement model? Okay, why do you say that, set model?
because it's a number of items.
Right, so the items are distinct. There's a number of objects. Okay. Part B is how long has it been since you woke up? Okay, measurement model or set model?
Measurement.
Okay, oh, I just found the group chat. Okay, good. Measurement is time, so it's a time thing. There's not real, you could think of since distinct hours or something, but they all kind of run together, and so that's more of a measurement idea. Okay, good. Here's another one. How many people live in Ogden? Okay, measurement model or set model to answer that question.
Set.
Right, set. And why is that?
Because you need to know how many of the item you have.
Good. How about how tall are you? Measurement or set? If you want to answer that question. Okay, Melissa's got some good answers.
Measurement.
Measurement.
Yeah, measurement. Okay, good. Measurement because it uses inches or feet to all run together. They're not separate, distinct things. In mathematics, we have a number line. Okay. Number lines are very helpful. So I introduced that up there. Okay, you guys, I don't know how you guys feel about number lines, but do we all know and love number lines? Why are number lines so good? Why are they powerful? The number line is the measurement model. Okay, so they have they have 5 actual great thoughts about number lines. Okay, the first real good thought about number lines is just to kind of I'm going to draw an example here for you. Okay, so there's a number line. number lines show the whole numbers in order. Okay, when you're teaching students how to count and such, you will have this order idea that you need to figure out. Showing whole numbers in order. It also shows their relative magnitude. Okay, what that means is that it shows how far away certain numbers are. How far away is, I have a number line here that goes from 0 to 4. So how far away is 10 from that? How far away is 100? Okay, they have, when we look at them abstractly, these digits, they just have 2 digits there and 3 digits there, but it doesn't seem like 10, that 100 is much bigger than 10, but it actually is. It's actually quite a lot, much bigger, quite a lot bigger, but number lines give this visual depiction of it. The number line naturally leads to fractions. Students will ask, what values are between those numbers, okay? All right, so I got a notice that will end in about 10 minutes for this first session, and then I'll log you back in with another code. Okay, naturally leads to fractions. It also naturally leads to negative numbers. Okay, so we have fractions that go in the middle, negative numbers. Okay, what is before 0? Okay, that's what they will ask you. The students will ask you that. And I actually had one of my colleagues in my master's degree program. She actually said that this very question occurred to her when she was in 2nd grade. What is the numbers that go before 0? And that's where negative numbers developed, is that they developed from people who asked that question. Well, we're going to just assign it a symbol, and that's what it is. So we have negative numbers there. All right, so those are and the number lines are used. They can be used with all types of numbers and all operations. Okay, so our numbers, our number line is going to be a good model for us to see how mathematics works. All right, so we have our numbers, we have visual representations of how they work. Let's go ahead and think about an addition word problem. What we're going to do now is we're going to make up an addition word problem that uses 3 plus 5 in a real life situation. We're extending our models of measurement and set model. So here are the directions. Make up an addition problem using 3 plus 5. In a real life situation. Where you use so part A will be a set model to model it. Okay, and I want you in your notebooks to think of the situation, and then you want to draw a picture to illustrate the solution. Okay. All right, so go ahead and think about that on your own and share out when you have a word problem. You guys, you guys okay making up word problems? We'll start with 3 plus 5. Okay. It's like a kindergarten or first grade word problem. So when you have it, go ahead and share it out. I'll type out an example in our chat.
Okay, I have one, I think.
Okay, go for it.
Okay, so if Tommy has 3 blocks and Timmy gives him 5 more blocks, how many blocks does he have? And then I illustrated it. I don't know if you can see the paper.
Yep, there you go. Good. Okay, so let's see. Tracy says Bryson has 3 pieces of candy. His sister gave him 5 more pieces of candy. How many pieces of candy does Bryson have now? So good. Melissa says 3 stars plus 5 hearts. Okay, so we have 3 stars in her picture, and then she has 5 hearts. Now the question would be, how many shapes are there total? Something like that. Okay, so with word problems, you set up the situation, and then you have to ask the question about what we want your students to do and to look for. Okay, we can with Melissa's example, she can have 3 stars and 5 hearts, but we can also talk about how many more hearts does she have, and that denotes a different type of mathematical exploration. So it's great to have the question in there, and then you can match it. So but the situation is good. Everybody has some good situations. So Sid and Shelby have shared. Okay. Marbles are good to use. These are all set models. Okay. Great. Now it's important that when you draw these things, okay. So we have our example with the marbles. Anna has 3 marbles. And Jerry has 5 marbles. Okay, always try to keep your units together. If you say Jerry has 5, then you're like, well, what? Jerry has 5 what? Okay, and so you're going to have, we need to make sure that we put our units on and that we can say that have our question. How many marbles do they have together? Okay, so we have the same kind of object. We can combine them together. Uh-oh. I wonder why it's not appearing on the share thing. Let me go back to sharing that. Hold on. Somehow my screen mirroring turned off. Okay, so that's what we have there. So we can draw a picture, 3 marbles for Anna, and 5 marbles for Jerry. You need to label these right here. I'm going to back that up a little bit and give us more room here. Okay, So when we do our illustration, we can do some labeling on here to help clarify things. So these ones right here are Anna's marbles. And this one right here is Jerry's marbles. Okay. And we want all of them together. We can kind of do some more these braces, and we put the total. Okay, total will show them all together. It's important that when you do modeling with pictures, we want to show the, we don't want to have that many symbols, okay? So we'll show arrows, we'll show like grouping things, okay? We don't want to put like an add, subtract, or multiply, or divide symbol in there. Okay, so it'll help us when we get to multiplication to show what multiplication is without using a time sign, okay, when we do our pictures, okay? You can imagine these marbles as concrete marbles. I did a drawing there, so that's the drawing pictorial level of abstraction. And then we use 3 plus 5 to show our so we started the record again. Okay, different levels of abstraction. We can use real marbles for concrete. We can have this drawing here for the pictorial level, and then the numbers are for abstract. A lot of times we just focus on the process and not necessarily the answer. So the process of adding two numbers together and combining them. Now that was the set model. We're gonna do measurement model. Okay, so that's the next part here. So part B, we're gonna do make up an addition problem using a set model, a measurement model, sorry. And use a picture to illustrate the solution. Okay, so we're gonna do an example here. I'm gonna type one up in the chat, and then you guys think on your own. You guys did some good sharing last time on this last example with set model. Think of a measurement model. Same numbers, 3 and 5, but we need to think of a different context that uses, in real life, that uses measurement perspective. Okay? So this is a really good thing to do. I always love to tie math to real life. I love to have you guys find out where you would really use these things. And I think that you would find it useful, and I think your students will too. They will always want to know where they can use what they're learning in their real life. So elementary does have kind of some simple examples, but it's good to see the structure and see real life applications. So I had used a measurement perspective by using miles, which is a distance. You can use weight. You can use, what are the other ones that we had for set models? Yeah, time. You can use anything that measures something. Okay, good. Yeah, there's weight for cooking. Cooking is a good place. Cooking is something that you can use for measurements and sets, because you can put a couple eggs into a cookie recipe. You can put a cup of flour in there, half a cup of flour, and those types of things. 1.5 cups, or so it's good. All of those. Let's see. Shelby has a good one. Susie has 3 pounds of apples Not that the other versions aren't good, they're all good, but I'm just gonna pick one to do my example here with on the whiteboard. Shelby, Susie has 3 pounds of apples and Joey has 5 pounds of apples. How many pounds of apples do they have together? Okay. And now it's interesting to note that this is this measurement perspective. Even though I'm doing apples, apples are individual objects, but the measurement perspective has us do pounds of apples, which it doesn't matter how many apples you have, it matters how much the total weight is. Okay? So Susie has 3 pounds of apples. Joey has 5 pounds of apples.
It's not showing on the screen again.
Oh, okay. I went to chat. That looks like what's. Thank you. It looks like when I go to chat, it goes off this screen share. So maybe I need to turn screen mirroring back on. No, it still thinks it's there. Okay. Let me try this again. Nope. I'll stop it and then start it again. Thanks for letting me know. Okay. So Susie has 3 pounds of apples and Joey has 5 pounds of apples. And how many pounds do they have all together is the central question. All right, question mark. And what we want to do is we want to show a depiction of this with a picture. And I'm going to do it in a certain way to introduce you to the third section of our lesson, which is bar models. Okay, so since pounds is going to be some sort of amount, okay, like miles, we can do units like that as distances. I'm going to draw a bar or a rectangle. And I'm going to shade it red because it has, that's the color of the apples. But you don't have to like shade, you can just do a shade of gray. Think of red apples at first. This length right here represents Joey's apple. So I have these 2 bars down, but I need to label them so we know what we're talking about, right? Okay. Okay. So that representation is Susie's 3 pounds of apples. Okay. And you can even leave this last bar blank, but I'm going to color it green because they have colors available to me. But if you want to like just use it as white and the other one is gray with your pencil, that's fine too. This representation right here is Jerry's 5 pounds of apples. Okay. And we want to know how many apples they have all together. So we need to depict the total or the entire length or amount of pounds with the question mark here. Okay. That actually mirrors a lot of what we're going to do in part 3. All right, so there's my measurement model. Okay. So I'm going to just say just like above, I'm going to say that, see here we have the total. Oops, that's my eraser. Okay, so here's we have the total. Oh, it's the erasing. Off eraser. Okay, so we have the total here. And then right here is going to be the total. All right, measurement model. Okay. This is a good way to represent distances. Like I had John running for 3 miles, and then he ran 5 miles another day. Okay, so bars are actually really good. And this leads us in. Any questions so far? Okay. Right. In your homework, you're going to read about how bar models come about, but we'll make some comments here. Bar models are simple drawings that are a powerful method of solving problems. Okay. So we got kind of an introduction to it in this above example where they draw bars, and they're simple drawings to depict the relationships in a real life problem. Word problems aren't very easy to solve. Okay, and as you remember, being an elementary student yourself one day, you probably did have particular feelings about word problems versus just simple computations, right? And so your future elementary students will feel that same way. And and bar models are a way to help make this process of solving word problems easier. It's from Singapore Math, and so in the course standards we use the word strip diagram or bar diagram as well, but they're just like a bar, a rectangle, to help you illustrate the different relationships of the quantities that are in your word problem. How do they relate to each other? What are you looking for? And if you don't depict it with some sort of drawing, all of your students will just start guessing at what to do. They will just pull the numbers 3 and 5 and we'll subtract them or add them together or we'll multiply them. Okay, bar models help you know which operation to use. Okay, so they're very important. They've been very effective with Singapore mathematics. And that's one of the reasons why Singapore does very well on international math exams. So we've incorporated them into our core standards, and I like to call them bar models. Others like to call them like strip diagrams or something. So I'll put that language down too. They could call them tape diagrams. Okay, and so on. Okay, and good. So draw a bar model, don't guess. That's my motto here. If you find people that you might be tutoring or at your elementary school, eventually you'll get into some word problems here with this homework and later homeworks. You can draw a bar model instead of just guess. Or other type of drawing, but bar models are pretty good. So how do they kind of develop? And okay, so here's our development of them. They begin with drawings of actual objects. Okay, so we're going to be working in the pictorial level of abstraction here a little bit. And in my example, I said that Joe I used apples again. Let's think of something else though. Let's do blocks. Joe has 2 red blocks and 3 green blocks. Okay. Now, even though this is a set model, we're going to depict it with the same type of illustration of the bar model, okay? Bar diagram. So my question is, how many blocks? He have in all. Okay. All right, so what you do is that they start out with a depiction of the blocks. Okay, so I'm going to draw 2 blocks. Okay, and they're going to be red blocks. And he has 3 green blocks. Okay. Now what we want to do is we want to know how many there are in total. Okay, so since I drew out the blocks, you know what they are. And since we don't know what the answer is, we put a question mark to guide our thinking. Which quantity are we looking for? Which part are we looking for to solve? Okay. Now what they do is that they begin with these objects, but once you start getting more and more objects, the drawing of actual objects gets tedious. Okay, and you can give your students examples of this as in a progression. I drew only 5 blocks in my example, but what happens if I have 20 blocks and I want to add 30 blocks? I start getting to a place where I don't want to draw everything. Okay? And I need some sort of representation of those numbers of blocks. Okay? And that's where bar models help. You can draw a bar model with just 4 lines to make a rectangle. And you can make them relatively as big as you need. Okay? So in the derivation here, we progress to bars for larger numbers. Okay, and that's why labeling is important, because we want to label the exact numbers to help us solve the problem for the exact answer. So it also simplifies our drawing work. Okay. So when you start drawing bars, you need to label them with the quantities in the problem. And a question mark for the quantity you're looking for. Okay. All right, so here's our addition example. We had a bar where we're going to represent 2 boxes. So draw a bar here, 2 red boxes. So move back up a little bit. So this is something similar to what you've already seen. Give yourself some room around your bars so that you can draw like the labels and stuff like that. And so I'm going to pretend that this is like my pencil. I'm shading in this one here, just to make it a little bit different. You don't have to shade them if you don't want to. Okay. And so we have the first bar represents 2 red blocks. Okay. The second bar is going to be bigger because it is 3 green blocks. Okay, so you want to kind of help the situation a little bit by making the bars a little bit to scale, but it doesn't have to be perfect. But just make one longer than the other if the quantity is bigger, right? Okay. So I have 3 green blocks here. Now I've labeled my bars from all of the parts of the problem, and they all have a depiction there, and I need to finish my bar model with the question mark for what I want. Okay? That's the total I want. Okay? Any questions on that, an addition type bar? Okay? If you want to, and you'll be looking at this a little bit more in detail with the homework, but here's just an introduction to it. Well, I mean, that's pretty much all there is, but there's more examples in the homework, let's say. Okay. Now, even though we're not going to do too much subtraction right now, they do go over in the book subtraction example. Okay. Subtraction is, let's say that I wanted to know how many more green blocks I have than red blocks. Okay, that's going to be a subtraction type idea. Okay. We're looking for the difference. Okay. And so the subtraction example with the bar model, okay, we want to see the difference between the two, but if they're in a line, we can't see the difference. So we draw both quantities as different bars. Okay, this bar represents the 3 green apples. No, sorry, blocks. There we go. That bar represents 3 green blocks. This bar is going to represent the 2 red blocks. Okay. And we can just kind of shade one for color here. Make it just a different color, it's a different object. All right. And so when we do that, we want to find the difference. And so the difference is right here, this distance. Okay. And we put a question mark right there. All right, so this top bar represents 3 green blocks, the bottom bar represents 2 red blocks, and then the question mark is the difference between the two. All right, let's have you guys practice an addition bar model. We got 5 minutes left, and so that's all I'm going to do for instruction, but I'm going to let you guys do addition bar model and then show me up with the screen. Does everybody, yeah, so we can show me your pictures here. Think of your problem, think of a new problem that uses addition to solve it. You make up the numbers and you show how the bar is looking that you would do to solve it. Remember to label the parts of the bar, put a question mark for where you want your answer to be. So I'll give you guys a few minutes to try that. Now I'm going to expand my screen here so you can see everybody. And let's see how well you guys do on that one. Maybe you guys can share out though, too. So you can share out like what your problems are. Okay. All right, so, oh, it's not putting me whose name is whose. Yeah, so I have 2 people that are sharing right now. Go ahead and explain. Let's have you guys go first, but I don't know that it's not showing me your names. Yeah, sorry, I don't know. Let's have one of those people who have shared already share out, because I don't know.
So in this one, I have 3 daisies and 4 roses, and you're wondering how many flowers are all together.
Okay, great. Now, is that Ariana? Did you say that?
Yes.
Okay. And did I say your name right?
Yes, you did. Kudos.
Okay, good. Okay, so can everybody see when she talks?
Yes.
Yes, no, some people. Okay. So what do you guys think of her bar diagram and her situation and her work here? What are you guys' thoughts?
I thought it was good because she did two different kinds of flowers to kind of confuse them, but they're all flowers, so it works to do the block system with like the different colors, but they're different
Mhm.
flowers.
Good. Yeah. Ariana, looks like you did good work. Okay, does anybody else want to share? Let's have one more person share.
I'll
Someone
share
that doesn't
mine.
usually talks. Okay, Sid, go ahead.
Okay, well, Tony's gonna get a kick out of this, just saying. Okay, if Sydney brings 1 cheesecake to class and 2 oranges to class, how much food did she bring to class?
Ooh, that sounds yummy. Okay, so she has the cheesecake and oranges, and she categorizes them as the same type of thing as food. Okay, so it's important that they're the same in your word problem. Good. All right, and any questions? Everybody doing okay with these? Thanks, Sid, for sharing. Looks good so far. Okay, so hopefully this will give you a good background and good background knowledge for your homework, and that you can understand what the book is talking about, that you can understand what the homework questions are. If you have any questions about those things, please let me know. We can do email, or you can do a Zoom chat if you have more in-depth question. That's all I have for today.
Thank you.
Yeah, you're welcome, everyone. I hope you have a wonderful Wednesday.
Thanks. Bye.
Bye.
Dr. B,
Yeah.
on the fluency journal where it says we're supposed to do like a mini problem that we did in class, do we just use one of these examples for that?
Okay, so let me go to that part and see what you were talking about.
I was trying to find it real quick so I could use the exact term, sorry.
No, that's okay. I also need to see what you mean. Okay, so it's in the fluency journal.
Yes. Let's see.
Oops, not that one. Yeah.
So it says each day record the warm-up activity.
Oh, nice. Yeah, do your own. Well, yeah. So I was gonna do a warm-up activity as a 30-second challenge. Is that just on the directions for like weeks 2 through 14 or something?
It was just in the like general what we're supposed to be doing with the journal. So it's like after we're supposed to do.
Each day record. There it is. Remaining instructions. Each day record the warm-up activity that you worked at the beginning of class. Okay. So in the beginning of class, if we were in the classroom, we have books that we can work out of. We have games that you can play with like dice and cards and stuff like that. Did I send you an email of possible activities? I don't think I did, because I think we're still introducing them.
I don't remember one, so.
Yeah, so we're still introducing them. I was going to go ahead and in my lesson plans plan an activity that you can do, but I want you to also do some on your own. So you can do that optionally. You can just record some activity that you've done. Could be related to our lesson, because all our lessons on arithmetic fluency. You could do one from the 30-second challenge app. Did I tell you about the app?
Yes.
Yeah, okay. Do one of those. You can put in there. And I'm going to try and look for some too to do. And the next time I'm at school, I'm just going to pick up a book and do one from the books every day. It's just a sequence of like 10 operations on numbers, and you see what the answer is at the end. So that's what the warm-up activity will be. But for right now, just put any math activity down there.
Okay.
And I'm only going to look at really completion and just progress just progress on how you do with the fluency. No, yeah, that's on test now. Okay, just for completion on this journal, and how if you filled out all the parts.
Okay. Thank you. I appreciate that clarification.
Yeah, you're welcome.
I had a follow-up question with that, where it says to do it every day. Is that meaning like every class day or every day?
No, class day. On the weeks, they have Monday, Wednesday, Friday. But you can do it every day if you want to.
Okay, thank you.
Yeah. Any other questions?